Hi, Jacek. Can you hear me?
Hi.
Hello. Yes, please. Yeah.
So in the steps 128, I have error when I put the policy ARN to this S3 bucket I created originally in the beginning, and error says the policy has invalid resource.
That's right. I think you might be trying. Are you copying the ARN example from the instructions by any chance?
No, from my real bucket.
Okay. If you want, you can leave it there for now. It's simply because we're due to be back in 2 minutes.
Okay. Okay.
Are you happy to do that, and we can have a look at it after we're done with the next teaching part?
Yes, of course. Yeah.
Okay, that is perfect. And we'll do that there. You can just leave the lab running, and it should be okay.
Okay, cool.
That's perfect. It will be an easy fix nonetheless, but just to make sure we don't steer away, basically. Welcome back, everyone. Hopefully, we are all back. Give me a quick thumbs up or a +1 in chat, please, if we are back and ready to have a look at a few other bits and pieces. Welcome back, everyone. I can see we're all back. That is fantastic. That is always a good thing, of course. Hope you enjoyed lunch. Hope you had a good lab as well. And like we mentioned in chat, yeah, it's like if any, well, on that issue, we'll sort it shortly as well. But just to make sure, of course, we are still in time with everything. So we have one more teaching session to go through, this one right here. It should take us round about an hour or so, an hour and a few minutes really, due to covering questions and all that. Then we're going to have a quiz, feedback as well, and we're going to go for the last lab of the day. So we can, of course, take a coffee break later if you want to, but at the same time, it's just one stretch left. So I think it might not be that mandatory, but by all means, if anybody wants a break in between later on, do let me know. Right. Since at the end of the day, we will do lab number 7, please also launch lab 7. You don't have to stop the current one, you can launch lab number 7 without stopping the current one. Let's get rid of some of these things. And let's see, the lab link should be here. There we go. So lab number 7, everyone. Since it's going to be the last activity, there we are. I have 2 labs running as well. The other 2 of today. Hit launch on number 7. So it's ready for us once we get to it. Okay, as the resources are loading, let's ourselves have a look at a few bits and pieces here to finalize the edge conversation. Because we looked at CloudFront before we went for lunch and lab. So we went through the edge caching and content delivery network solution, which is Amazon CloudFront over here. But technically, there are more things we can do at the edge, including having our DNS solution there as well, and a few other elements in terms of overall edge, not just edge locations. The idea is to cover different facets of lower latency and reachability to customers. We can use edge locations to bring content closer or local zones for similar purposes, but also compute here as well. We have outposts, which we've also covered for the same dual purpose of compute and data as well. And we have the Snow family, which technically could also bring compute, but it's more a data solution for data transfer rather than long-running compute. And we can protect using the edge by leveraging web application firewall, shield, and a couple of other services as well. But these 2 together will really help us from a edge protection solution, and we'll see these shortly as well. However, as you've seen previously, you've created in your lab a CloudFront distribution with a DNS name, which was not, let's say, the most human-friendly one. That's where Route 53 will come into play as Amazon's DNS resolution service. So DNS is the ability to resolve domain names to IP addresses. We as humans don't really remember numbers associated with servers, but we remember names a lot easier. Route 53 is a play on words from the Route 66 highway in the USA, and the port 53 which is the DNS port. So I think that's a pretty nice way of naming it. It also allows you to register your domain names, so it acts as a registrar as well, and it can perform various clever routing decisions based on DNS. And where it lives at those edge locations. So before we dive into it further, I just want to show you one thing here. If I go to my console and we look at my DNS solution, okay, I need to log in again. There we go, Isengard as well. Oh, the lab number 7 is ready already, so that was quite quick. Okay, there we are. Loading the solution here. There we have it. So if I go to Route 53, everyone, we will go to this place here, to our DNS service, and we will be able to see that I have a few hosted zones, a few public hosted zones, that is, of course, because that is where I register, that is where I have my name server definition to host my own DNS names, stefanbuse.aws.com or stefanbuse.com as well. And we'll be able to see in these ones that the name servers that we have use a striping and a spread logic across multiple name servers across all of those edge locations for high availability and redundancy. So it's quite resilient, to say the least. Route 53 in that respect. Now that is a publicly reachable domain name, but we can also have private hosted zones for intranet solutions. And of course, you don't have to register those domain names, but they're essentially utilizing Route 53 resolver as a way to internally route based on DNS. Or you could use public hosted zones to enable public-facing clients to resolve their DNS queries to your Route 53 servers. And the way we achieve different types of routing is through these ones here. And technically, there's an IP-based routing as well, so there's an extra one here. So let's have a look at them. Simple routing is just as the name implies, simple routing. If we have other endpoints, the first request goes here, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. Simple round-robin routing. We don't really look at the endpoint health. We don't go by any logic. Just simple, really. However, we want to make sure that if one of these fails, we stop sending traffic to a failed endpoint. And that is what failover routing will do. Failover routing will have a main endpoint here that will act as the main destination for our routing. But if it fails, we reroute the request to the secondary region as well, or the secondary endpoint. These could be both in the same region. We get to choose those elements. But what if we want to send data to both of these, depending on where users are? Ultimately, think of it this way. Let's go global infrastructure. If we take the map, and we place it here. Let's say we use this region, and this region. If I have customers, let's say London, Sydney, I have to check actually if the top one or the bottom one is Sydney. I do apologize for my geography, and I'm going to say North Virginia here, even though it's probably this one actually. But there we have it. Let's have some customers. As well. This customer, we would want to route to Sydney, highly likely this customer as well to London, and this one to North Virginia. That is where the next routing policy will help based on the location of these customers. We will have geolocation routing for that. We look strictly at the position in the world of the user and route the user to the relevant location. Europe-based user to EU West 2, US user to North Virginia. The thing is, though, the world is uneven. So imagine Europe. It is a cluster of densely packed population, whereas Africa, for example, as a continent, is much more spread out. Same as different parts of Asia, but maybe probably like this, actually. It depends a bit. So if we evenly distribute by location, we might unevenly overload some regions. So what we can do in that respect is influence what the map looks like. We could redraw the map, and that is geoproximity routing. Geoproximity routing gives you the ability to influence what the map looks like. Let's take this user here. Purely based on geolocation, they'll go to what seems to be the Paris region here. But if I reduce the bias here by simply configuring some numbers here for the geoproximity, the map will be somewhat skewed, maybe looking kind of like this here. There we go. Let's say something like this. Now, the user no longer goes to the Paris region because as far as the map representation seems, it's going to have to go to this region over here, to the South African region, I believe Cape Town, if I'm not mistaken. So this is how we can influence the localization of our customers. But let me ask you this, everyone. In this case, actually, regardless of borders and regions and all the rest, which region is this user going to connect the fastest to? Is it Paris or is it Cape Town? What do we think? We have a mention for Cape Town privately. Paris 50-50, depends. It depends. You're absolutely right, Jacek. Distance affects latency, but it's not all. It's not all. If there are 3 hubs up to Paris, or let's say if there are 3 hubs to Cape Town, but there are multiple hubs to Paris, this might take longer if it's a clogged network. Similarly, so latency-based routing won't care specifically where you are in the world, but it will rather check the endpoint's connectivity speed and direct you to the lowest latency endpoint based on your location. Another routing policy is multi-value. And multi-value, think of it like simple, not so simple. In other words, we check the health of the endpoints and we return up to 8 healthy endpoints. So the client can make a choice in between the healthy endpoints to route to. It's a more clever, simple routing policy, if you will. Lastly, maybe we want to control the percentage of users. And that is where weighted routing comes into play. We can decide to send just a certain percentage of traffic to one particular endpoint and a small amount of traffic to another endpoint as well. Maybe we are deploying a new environment in that particular secondary region, so we don't want to shift all of our traffic there. Maybe we're migrating as well, so we want to do it gradually. There are different reasons why we might do this, including disaster recovery reasons, which is what we'll see in the next module shortly. Ultimately, everyone, you can mix and match. You can do that by enabling something called traffic flow, but the idea and the recommendation is to mix and match. Ultimately, even if we use weighted routing here with 10-90%, we might want to add failover as well. Because in case one of these regions fail, even this one, we can shift all the traffic to this region because of the failover policy, for example. So it can be very, very useful. Let's have a look as to how this works. So there we go. Let's close this. And let's see. I haven't tried this configuration yet, but let's see if it works. So from a different course, from a different demo, but still a very nice one, a serverless note-taking application. I believe we might have shown this one, the demo Polynotes app. Does anybody remember the demo Polynotes? Did we show this, everyone? It's not from this course, but this one right here. We might have shown it briefly, if I remember correctly. This one here, Baby Groot needs more time to wake up. You can see there were some funny inputs there as well from Yep. So, Jacek, can we modify settings dynamically, for example, depending on the day time? Are you referring in row 53, Jacek?
Yes. But Nikos probably gave me answer. Yeah.
I think Nicholas was answering on whether we've seen the Polynotes app there. So we, not as far as I know, dynamically here in row 53, but what we could do, Jacek, is this. We could go to Event Bridge and create a schedule. And this is a schedule that we define. We choose the rate expression, essentially, as to how often something needs to happen. So let's call this demo, and we would say recurring schedule, rate-based, depending on the daytime. So let's say every day, no flexibility time window. Start time, shall we say 12, well, today as date, and start time 12 at lunch for about 3 weeks there.
Yeah.
So we define the window, and then we choose a Lambda function. And in this Lambda function, we can essentially write the code, say my function, let's see, AWS Python route 53, change configuration. Change resource records. That's potentially no, actually. Traffic policy or update traffic policy we should have. Yes, there we are.
Okay.
Update traffic policy. And that's how we could do it, for example. We would take this code for update traffic policy method on row 53. We would put it as part of a Lambda function, and we'd basically just switch back and forth depending on what you were thinking there of an architecture.
Okay. Yeah, brilliant. Thank you.
No problem at all. And do you have a specific use case in mind for that, or?
No, just general. I mean, depends on the traffic because, for example, we want to have something like afternoon traffic should be forwarded mostly to Europe and, for example, to Japan, or depending if the China the Easter sign has night, maybe we wish to forward more traffic to the east, or make it, the eastern zone, make it bigger to absorb more requests, something like that. But probably it will be fixed that dynamically because you said earlier that it detects ongoing the response ping. So if the response is too long and there is short somewhere, then it forward the request to the new zone. Okay.
Yeah, that makes sense. Might be something that traffic flow could do in that case, actually. So
Yeah.
I don't yet. So I don't have traffic flow enabled here, but this is what it would look like. Basically,
Okay.
define the whole flow of traffic. I would have to check if we can actually do it by different times of day in that particular way. But I do have another alternative architecture here. So something simpler instead of updating row 53. Let's think of it this way, Jacek. Let's see. We have a region with availability zones and the like. So let's see, region. We have route 53 here at the top. We have region 2. Okay, there we are. Let's get ourselves a VPC. Some subnets as well, ultimately. There we are. Just make this a tad bit smaller. There we go. Let's get ourselves a load balancer, ALB, internet gateway, all that jazz, basically. I'm just wanting to put this infrastructure in place so we can have a look at it. And let's make sure we, let's make sure we get the cross. There we go. What we could also do we want to keep traffic going here and here in both situations? We just adjust the flow, or do we cut it over?
Well, it depends. Maybe both. That depends on the time zone. Well, actually, I don't know.
Okay, let's do both in that case. So direct cutover of traffic. So Route 53, with all routing policies apart from simple routing, will be able to do health checks. Health checks are going to be mapped to a specific endpoint or a specific path. So if we go to health checks, we would see that we can configure a particular endpoint to monitor. It doesn't have to be your actual website. So the reason I'm saying this is you could check an endpoint here, maybe of an API or something along those lines. A nice and simple endpoint in that respect. And if the endpoint is healthy, then you route traffic to this solution. And instead of tweaking the routing policies, you tell EventBridge to just stop this endpoint every 12 or 24 hours. So when the endpoint essentially becomes unhealthy, that is when we cut over the traffic as a failover to this solution as well.
Okay, just for example, if you want to do in R1 some updates or maintenance. Yeah.
Now, in order to shift traffic gradually, depending on time of day, I can think there potentially, so either like we said with EventBridge or perhaps with code deploy. So we don't really explore code deploy here in this course. But what does code deploy do? It gives you the ability to incrementally shift traffic. Let's see. I want to see if I if I can find an image quick. There we are. So I can demonstrate this as well if you want to. But the idea is it will gradually shift traffic from one endpoint to another, from one deployment to another. And it is able to do so with load balancers, APIs as well. And let's see if we can choose Route 53 to change the weights, basically. Doesn't mention here. Load balancing, yeah, it might, there we are. So we can use Route 53, but as a blue-green deployment. If it's not directly, we could definitely configure it. So there are options, is what I'm trying to show. Probably better, actually, than just changing the routing policies themselves.
Okay, brilliant. Thank you.
No problem at all. Just having mentioned code deploy here, everyone, we definitely don't cover code commit, build, and deploy as a CI/CD pipeline as part of this course, but if you want to learn more, as always, please let me know. So everyone, as we've seen, this here is Route 53, and we were going to effectively try to get our Polynodes app to have, instead of a CloudFront distribution name, let's try to make it have a nicer name here, hopefully stefanbuse.com. Because what you can do in Route 53, very nice and conveniently, you can create alias records, which is an AWS specific record. And as an alias, we will point to AWS resources. And so let's see, let's point not to an API, my apologies, to CloudFront distribution. And it doesn't see it in here. So apparently it doesn't quite work that way yet. Here, unless I am rushing here and doing misconfiguring something. Yeah, I'm definitely misconfiguring something, but let's go with a different one then. Let's create a record. Simple routing. By the way, there's IP-based routing as well. IP-based routing looks at the side range of your corporate network and restricts traffic, accepts traffic only from that network as well. So this is, I believe, Jacek, also you asked, how could we send to CloudFront? Well, restrict to the side range of your network through Route 53 and send that to CloudFront as well, as an example. Okay. Okay, so I can't find that distribution. It seems I might need to configure some. I might need to check the configuration here. So let's see. As well, if I can notice quickly. And if not, we'll just try something else or leave it. That idea. You might not have permissions actually. So as well, I need to put the alternate domain name. Actually, no, we don't need to use the CNAME. All right, no worries. Let me try something simpler here, so we don't spend too much time updating those elements. Let's see stacks sam app 6. Good. So this works. I will go to that hello from Lambda in Route 53. So we're going to choose API gateway. Virginia. Interesting. Okay, so I can't route to that either. Right, I'll have to double check here. I'm definitely missing something, probably quite obvious actually. We could definitely route to load balancers, but mine are shut down at the moment. No worries, I'll get this one set up and we will see that as well. So the perks of live demos, everyone, doing some elements in that respect. Can I edit this one perhaps? Action. Yeah, no resources found for some, it seems. That's right. I'll double check what that is and I'll get this set up. Right. In any case, I could have routed to those resources, and based on that, we could have essentially gone to via public stefanbuse.aws.com to my endpoint. I will get that set up for later whilst you are doing the lab. Ultimately, everyone, we can use DNS here to route records intelligently at a global level. So in a way, you can think of this as a global load balancer, but I would not call it a load balancer officially because it just has load balancer-like capabilities rather than being a load balancer in itself. Now, what about security, everyone? Being able to have those many edge locations means we can protect ourselves quite well from volumetric attacks, which is what distributed denial of services attacks, or essentially, whenever you receive a text message or an email, or even through other means that say you have a parcel at customs, you need to pay 0.13 to retrieve it, or you've been selected to participate in a one out of two chances draw to win £5,000 and those kind of elements, scams in other words, or basically phishing links and the like. Someone could try to essentially corrupt or get access into your device, phone, or laptop to use it as compute to make malicious, bogus requests to a target they don't like, which could be a website of a competitor, or quite simply something that the attacker holds a grudge against. It's not an attack where the attacker is trying to steal anything or compromise any credentials. It's just trying to overload the end target by taking advantage of a large amount of other devices. This is a distributed denial of service attack because if there are legitimate users trying to access the website, because of this volumetric number of requests here, they might not get through. So their service is denied, essentially. And you, as a solution, you're not able to sell products because you can't reach the end customers. So we need to protect against that. And it usually takes a higher level of compute to take down a smaller level of compute. That's the rule of thumb. So everyone, those DDoS attacks can happen in various ways at different layers of the OSI model. We could attack the TCP layer by not completing the three-way handshake. We could just leave it hanging. We could attack with UDP reflection attacks, just simply overloading the end solution with the UDP requests. We could perform multiple HTTP requests or flood the DNS. We could perform slow lorry attacks and more. There are quite a few ways to attack a solution to deny service, and Shield is the way to protect against DDoS. In the Shield standard version, protecting layer 4 of the OSI model. It is on by default and it is free. It basically protects infrastructure level solutions and network level by protecting elements such as security groups, NACLs as well, they're more data center based functionality, and your edge locations. With Shield Standard, though, with Shield Advanced, though, you get the full set of protections on DDoS all the way to layer 7, because layer 7 DDoS attacks are clever. They're more complex. They're more difficult to patternize and eventually learn how to deflect them. It does come at a price, though, of $3,000 per month. In that respect, so it doesn't come in cheap as well, but it does offer two great benefits. It does offer some more, but these ones I'm particularly keen on. 24/7 SRT availability, Shield response team, a team of Shield operators, if you will, that will help you navigate an attack and try to find patterns and ultimately deflect the bogus requests. It is tough to identify straight away that you need to reject, accept, because you need to analyze those requests. And if the requests are clever enough to imitate legitimate requests, it's going to be difficult to start dropping them or rejecting them. So to make sure our customers aren't faced with difficulties, what should we do here in the initial stages of the attack? as the target. Remember, it's quite difficult to start accurately deflecting the malicious requests. So what should we do as a target to make sure we're still on? We should scale, Dave. Absolutely. One more instance, one more instance, one more instance. So ultimately, we're saying just add more resources. And if we're using AWS, technically, to take down AWS, you need to have a solution bigger than AWS. Because like we said, as a rule of thumb, you need bigger compute than the compute you're attacking. And with 32 regions worth of compute, that would be quite difficult. What is the downside of that scaling, Dave? Cost. By all means, cost. So it would be costly to absorb an attack. However, if we check Shield Advanced, over here, beyond additional types of detections and analysis and support, notice what this says. Cost protection from scaling due to DDoS attacks, meaning there is, think of it kind of like an insurance policy where you don't have to pay for all of your deployed resources as part of scaling. It's a slightly oversimplified statement there. It is something to be looked into at a high detail to see how it works exactly, but it does offer that benefit as well, in addition to a few other benefits. So it is definitely something worth looking into, despite that particular first possibly pricey entry tag. But this is really just for distributed denial of service attacks. Other attacks are cleverer. They're trying to take advantage of vulnerabilities, potentially inject bad code, and so on. And that is where more clever filtering rules with web application firewall should be used. Because WAF operates at layer 7, therefore it's able to see the full packet of information. And based on groups of rules called access control lists, we can set up how we want to protect and filter the requests coming in to various layer 7 and services, API Gateway, ALB, CloudFront, and more. We select the types of rules that we want, the types of reject sets, and so on. In that respect, we can log data about who's accessing, who's going through those rules. We can monitor as well. And then we choose the rules also, whether it's attack prevention, traffic filtering, and more. I will show you this in the console shortly. Matter of fact, I will show you now as well. So if we create a rule set, an access control list here, there we go, create ACL, web ACL that is, let's say demo ACL. We can choose to protect regional resources or CloudFront distribution. And then we add the rules. We can create our own as well if the managed ones don't satisfy. And there are quite a few managed ones to choose from. So let's drop these down. There we are. A couple of AWS managed ones as well, and others from third-party solutions, such as let's see, where was it? Top 10 Open Web Application Security project, top 10 rule set. So the most common types of attacks at the current date, according to Cloudbreak Core and the OWASP organization. Or we could look against SQL injection vulnerabilities or vulnerabilities to PHP, or Amazon's consideration of bad IPs in the world. So there are quite a few rules that we could add. And like we said, we can create our own. And then we choose, do we block or allow the traffic? At first instance, you might be thinking to block, but if you're working on a more security-based approach, you might also allow it into an instance designed to inspect traffic and not actually be part of your production workload, because you might want to investigate. And there are more security services, everyone. Technically, these are rules to control traffic. Security groups are rules to control traffic. There are others as well. Most, I'm not going to say all because some of them are not, but most of them can be managed into the firewall manager, including something else called the network firewall. So there's quite a few different types of security aspects here that we can use. Firewall manager can go across accounts as well. And if we take other security services such as guard, duty, detective, as well, IAM for policies, we can put it all on Security Hub. Basically, the one-stop shop for security and protection needs. It's not part of the course, but I do recommend you have a look at it at Security Hub. It's basically the solution where we integrate pretty much every security tool in AWS. There might be a couple not currently integrated, but it is basically the central location for security. There we are, Inspector, Guard, Duty, even Macy for detection of personally identifiable information in S3 buckets. As well, Systems Manager, Patch Manager, Firewall, Detective, Config, and more. Ultimately, everyone, we want to make sure we have a DDoS resilient architecture. So whilst we started off by building this architecture right here, now we are taking our protections to the edge by leveraging Shield and WAF for DDoS and filtering to protect our CloudFront network of edge locations. And we are also using Route 53 to resolve our DNS in a performant and secure way as well. Before we very briefly reinforce the knowledge on outposts, do we have any questions here, everyone? So any questions, or do we have a +1? Or a thumbs up, of course. Andrew, how can you tell if a DNS entry is still in place?
Yeah, so Route 53 entry, sorry. Yeah.
Okay. So how do you mean if I have an active...
So, yes, so what we've got is people have done things manually in DNS, we got it in code, and we don't know quite what's live, what's not live. So if we tidy it up, are we going to kill something that's in use?
Absolutely. I would recommend CloudWatch for that, to quickly see that aspect, and logging as well. So let's check in CloudWatch what metrics specifically we have for Route 53. We should have elements relating to amount of requests, I would suspect, but best to check. Route 53 hosted zone metrics. This is the only one we have. DNS queries. Okay. And this is per hosted zone. by the looks of it. So it doesn't seem to be granular enough for each DNS entry here for each record. But we could configure one of those custom metrics if we needed to. So that's how I would do it personally. And then look at the ones that actually generate requests. Now, are there logs as well that we can look at? Let's see. Taking a bit of time here. Come on, CloudWatch. Any second now, CloudWatch. So, right, it's taking some time here. We'll see if it brings those up. But even on a record, let's see. So we can configure these ones. I was just trying to see if we can configure logging from here specifically, or would we have to customize it a bit? But Route 53 should be able to also, there we are, query logging as well. But that is for Resolver, as I noticed. There we are, 53. Okay, so it doesn't send logs to CloudWatch logs by default, but we should be able to configure it to do so as well. Definitely for Resolver, seems to be able to here. I would have to find exactly how to do it for the public hosted zones, but we should be able to as well. And hosted zones tags. There we are, directly here. So that's how we would send the logs. And another way, this is another way we could find that as well. So perhaps instead of just looking for metrics, you could configure logging, and then you would go to CloudWatch logs, look for your log on a particular domain name, and if you find entries, it means it's still being used.
Okay, thank you.
No problem at all. I should mention though, Andrew, this is a bit of a manual approach. It is a clever way through Log Insights here to run queries as well. So there are some quite capable and automatable ways also. There we are. So we can run queries on logs to sort as well. And if we configure this query in a programmatic way, maybe through a Lambda function ran on a schedule, you could simply do this really hands-off, essentially. There we are, even Route 53. There we are. This might actually be something very close to what you'd be looking for. So quite a few ways here, Andrew. And does this make sense?
Yeah, I'll have a look at that. Thank you.
No problem at all. That is perfect. All right, everyone. Let's just making sure, doing something here as well. Yep, that's all right. As I want to make sure I am able to show you one aspect here. And in the meantime, do we have any further questions? But I think it seems like we are okay. Right. In that case, everyone, Outposts. What can you tell me about Outposts, actually? Because we have talked about this. Again, one of those shots in the future, one of those leaps into the future, if you will. So what can you tell me about Outposts? Any thoughts? On-premises? On-premises, AWS equipment on-premises, absolutely. Can we get all the services on AWS Outposts? Could I get DynamoDB, for example, do you think? No serverless, absolutely. Now, I will say, though, there's a small caveat to that statement. AWS SAM is able to run local Lambda functions for testing purposes. So if you run SAM on an EC2 on an outpost, technically you are running Lambda in a localized way in your outpost, but that's a very convoluted way of saying it's possible. The idea is there are some pretty cool flexibilities there. In simple terms, though, Outpost is that physical rack of servers of a standardized 42-unit solution, or a 1U or a 2U, usually referred to as the pizza box sized outpost. Kind of an American pizza, though, because it's a pretty big box still. Like we said, it does come in a few shapes and forms, these two right here, and you rent them for 3 years. AWS will be responsible for the maintenance of them, but ultimately, you are responsible for the physical security here. So, are you responsible for anything physical on, let's go with DynamoDB. Are you responsible for anything physical there? No, absolutely not. So an outpost is going to be in your building, however. So you are going to be responsible for that physical security wise, because you're shifting that responsibility more towards you. But AWS is still responsible for making sure it works, and the idea is that it is connected to the cloud. So it seems like something you could just use on premise, but it is really just designed to connect to the cloud as well. And this connection could be, what do we think it could be? One option or the other. We've learned about them just a couple of hours ago. Direct Connect and VPN, absolutely. So that is how Outpost is meant to be used. But of course, there are use cases such as this one right here, this typical Outpost, where a gambling agency from, I believe they were from Netherlands, no, from Germany originally, has expanded their market into United States, into New Jersey, more specifically. And the data regulations there, enforce having the data within the 4 walls of your building. So they required an outpost for that. Nikos asking who's pay whom in this case. My apologies, Nikos. I'm not sure I understand. Is it with outpost?
Yes, when you have the physical machines on your own room, with your own server room, with all the infrastructures, and then you rent them to AWS, or you pay AWS to use the services. Who's pay whom now?
So this is not your device. Outpost is not your physical device. You're not purchasing it. You're basically sorry.
My servers are, right? I have my own servers on my own room.
No, Nikos. My apologies if I misspoke there. Outpost is like you ordering a box from Amazon. They bring the physical server and you rent it. Okay. See how I say place order here? They're going to come from an AWS data center into mine.
But then how can we look after the physical machines? If just it's not in our area.
Sorry?
I got confused a little bit now. Sam, earlier you said about you're not, the AWS is responsible for looking after the overall working as well, but you're looking after the physical infrastructure. But if it's not on my end, how can I do that? I got confused a little bit.
That's right. My apologies if that was unclear. Let's have a look. This is where Outpost is. So this is where the Outpost is. We place an order. Based on this order, AWS dispatches the Outpost and sends it to you, the physical machine, the the physical box. They are responsible to send engineers to fix it, look after it in that sense. So you're not meant to tinker with it physically to try to fix it if it breaks. That is where an AWS engineer fixes it. But you are responsible for locking your building at night to make sure someone doesn't come and steal the outpost away.
Okay, makes sense now.
Does that make sense,
Yeah,
Nikos?
now it's clear. Thank you.
No problem at all. I was just trying to illustrate that with Outpost, you are also undertaking more responsibility, because with an EC2, if there's a malicious person trying to steal the data, the physical drives that host those EC2s, there's nothing you as a customer can do about it, nor should you. It's not your responsibility, basically. That's the idea. All right. So, everyone, that is perfect. Do we have any other questions here on Outposts by any chance? And let's move to a slide where we see the services as well, the ones that can be used on Outposts, but I believe it might be a little bit more now, actually. We are always working to expand these elements. So before we move to backup and disaster recovery module, do we have any questions? I can see the thumbs ups. That is perfect. Fantastic. All right. So, in the meantime, I quickly also made sure this actually works. Fingers crossed that I'm not presenting a broken. There we are. Can you see this, everyone? So this is not to CloudFront, it's to my application load balancer. But essentially, instead of the demo that we had yesterday of high availability, now I'm going through Route 53 as my DNS server. So is it working for you as well, everyone? With over HTTP, not HTTPS indeed. So I don't have a certificate attached here, but we could do that also. Yep, there we are. And that's how we would do it. So what I've done is essentially in my hosted zones, in my public hosted zone here, I configured one of the records to point to my recently created load balancer here. I will have to check what I was missing there with my CloudFront distribution. Reason why it wasn't working there, but must have been a very silly user-related error on my part. The idea is this is how we would do it. And if I configured the other weighted record with another load balancer, half of you would get one record, half would get the other. There we go, a Spanish load balancer as well. But for now, we understand the concept. We have seen how it works. Let's now head over to look at a pretty short module here about backup and recovery. So this is really a culmination of what we talked about from an architectural perspective. So we will talk about different types of strategies of recovering from a disaster. How do you currently achieve this? Any question, any thoughts, everyone? How do we do this?
So we have a mixture, probably quicker to talk than type, sorry. So we use AWS backup recovery. We do for rebuilds for some of the older application types and restore the data from S3. So we've got lots of little nuances, really.
That makes sense, Andrew. I expected nothing less. Since you mentioned earlier on, you were using quite a lot of the AWS suite as well, including S3. So that is actually a very sensible aspect there. But I would also expect it's not a very known fact across the organization, isn't it? Backup tends to be a quite specialized team's responsibility, or at least disaster recovery strategies.
Yeah, we've got individual people that are responsible for it, but as a team, we have to do the playbooks and exercise the playbooks and make sure it works.
Absolutely. That makes perfect sense, Andrew. And thank you very much for that input. And we have a few mentions in chat as well, with possibly E, and depending on the system, of course, Dave, absolutely. Different services will perform different aspects. They will back up or replicate. That is all part of a disaster recovery strategy, and that's what we will look at here. To help our CTO centralize backup solutions, as well as find out how to better protect ourselves as a business. So, in terms of planning for a disaster, it's best to test how things work, look at your resources and understand their behavior, especially in the case of a failure. Plan it in case something goes wrong, or not in case, but rather when. It's statistically speaking, it's a guarantee at some point it will happen, whether it's tomorrow or in 1,000 years from now. Statistically, if you do something long enough, eventually it will change or break. So definitely run those game day scenarios to test them. The idea is to implement everything that we talked about from a reliability perspective. Use multiple availability zones in a high availability fashion. Fault tolerant solutions, as we've seen, serverless is more fault tolerant by default. Back up your solution automatically and with manual snapshots as well. And then plan and test of how you would recover in case something actually does go down. If there's no data governance in place that limits you to one region, then use two. Even if in the second region you have nothing running at the moment in time, that might actually be one of the strategies. You might be favoring cost, but at the same time, you have an auto-scaling group with a minimum of 0 and a maximum of 100. This is not costing you anything, but in case this fails, and you've configured other elements in place, then we can go from 0 to somewhere up to 100, so we can take that workload. That's what we will explore as we talk about RPO and RTO, which mean the frequency of your backups or your snapshot solution dictates the maximum length of recovery point objective. The way I remember it is RPO, P for past, in the past point objective, which means if you take backups every hour, let's say at 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, it means that the very most you could lose is 59 minutes, 59 seconds, and so on. So 1 hour. That is your recovery point objective. Now, let's say RDS goes down. How long until you get a new RDS? Let's not think multi-AZ, because that would be just a few seconds. But let's think restoration from a snapshot. How long do you think? Any thoughts? Anything at all. There's no right or wrong answer. It's just an architectural discussion.
When we restore like a volume from a snapshot, it takes about 10 minutes probably. But it's not RDS specifically. I've never done an RDS restore, so don't know.
How large are those testing volumes by any chance, Andrew?
Some are quite large, but doesn't really seem to make that much of a difference to the size of it. But I suppose it must do. Yeah.
To some extent, absolutely. If we're talking a few 100 gig, yeah, absolutely, should be quite all right. But what if we're talking about a 50 terabyte database? Yeah. Probably a little bit longer. It will be quite efficient still, but it will be longer as well, highly likely.
Yeah, when we restore our Teradata database, which is about 90 gigs, it takes 18 physical hours plus database time on top of that. So
there we are. So quite a bit. And I think you mentioned 90 terabytes for that one?
Yeah.
There we are. So as an example there, absolutely. So should we say about 10 hours here? And like you mentioned, that's a very good point. Plus the database time, plus identifying that you're actually down. Because what if you have no alarm in place or those kind of elements, then you would be down, but not attempting the restoration because there's no monitoring. So all of this will result in the RTO, recovery time objective. T for future. Yes, that doesn't work just as good as RPO, but now there we are. Not all of the analogies fall in place, if you will. The point is, these are not configurable options. They are results of your configurations. And there are many things you can do about changing these, and we have looked at them. There we are. How can we get RDS from hours to seconds? And we did mention this just a couple of minutes ago. So from hours to basically seconds. Multi-AZ, as simple as that. It will mean you are running two databases in parallel, one in standby, one in live. But it will be a very, very, very quick recovery time objective. So different aspects that can be used for disaster recovery, everyone. Ultimately, S3 to store our backups and to cross-region replicate them for higher redundancy. Glacier to store them long time at cheap rates. Snow family to take data offsite as well. And others for performing backups, such as EBS with snapshots. Software backup. You don't need to have an EC2 running to back up your software. Just have an AMI, and that is your software definition, dependencies, libraries, everything, including the operating system, as part of one image. Yes, this will technically cost, since it's basically an elastic block store snapshot that has been registered as an AMI, but it is basically backing up your software here. Similarly, for container services with container images. Then, if something fails, what shifts traffic? Well, we just talked about Route 53 failover, elastic load balancing. You've tested this into the lab as well, and this is part of a network also. Of course, other connection types, direct connect or VPN as well, if we're shifting discussions from the on-premise to AWS. We talked about RDS, multi-AZ as well, and DynamoDB with global tables also. Not to mention, you can actually take backups of DynamoDB as well. So quite useful. Configuration backups and updates as well with CloudFormation and scripts in, for example, Systems Manager. Because ultimately, if your infrastructure goes down, you may have to recreate it. And what better way to ensure it's identically recreated, if not through CloudFormation? Many of these services can be centrally managed from a backup solution in the intuitively named AWS Backup. It doesn't cover every single AWS service under the sun, but it does cover quite a few. So you can centrally manage backups in AWS Backup on a schedule by having them in vaults as well. It doesn't actually cost as a service. And let me clarify that. The backup itself, let's say 25.3 gigabytes, yes, this costs storage, but the orchestration of this through AWS Backup is actually free. You can tag your backups and solutions as well, and you can have it all in one place, essentially in one vault, to which you define who has and who hasn't got access in that respect. You have a whole strategy of how to assign resources to a backup plan and how to get backup to run automatically, but this is more operational side here as well. The architectural intent we have addressed, and quite importantly, it works across organizations also. We haven't looked at organizations on all facets. Again, it's a much deeper service, but we can have backup policies also to conform across accounts into how we manage backups. Ultimately, everyone, it comes down to how fast and how cheap you want to recover, because there are multiple ways of achieving this in terms of strategies, as we're going to see right away with backup and restore. This is the cheapest solution, but the absolute longest. I'm going to say long because it does depend on the technology that we're using. It's the idea that you're running your servers and you're quite literally just backing them up, maybe to S3. In case of a failure, we use that backup that we've taken. Maybe this is a storage gateway solution, and we're taking those EBS snapshots from our on-premise iSCSI volumes, and we restore those EBS volumes as volumes here, and from there we launch our EC2s if they're registered as AMIs and all the rest of it. So it's cheap because you have the least amount of additional elements besides your production workload. A little bit more expensive but quicker is when we have a more complex solution, and this is Pilot Lite. We have a 3-tiered application on the left, and, well, a 3-tiered application here on the right, but it's a bit simplified. These are not running, so they're not costing, like we said, minimum 0, maximum 100. This, however, is live. It's a database secondary, it's a replication, and this is going to cost us, but it's only costing part of the entire solution instead of replicating the whole solution. This is a quicker recovery time objective and an almost 0 recovery point objective, but it does depend on what else is going on here. The idea is, if the production fails, you're just waiting for the recovery compute to come on live, because you already have the data, which tends to be the longest thing to come live. The other option is to keep everything live, literally in both places, but not to the same level though. You have 100% capacity here and low capacity in the recovery environment. What is the benefit of keeping them running besides the fact that you can shift traffic almost immediately? Yes, some customers will not have downtime, others might do, depending on how much volume is being sent to the recovery endpoint. But what is another benefit that you get here that you do not get here as easily or at all? That is absolutely perfect, Andrew. It works. You know you have peace of mind that it works. It's basically continuous testing. Normally, you have to test your recovery environment to make sure it works so that you're prepared for a game day. In a warm standby solution, you know it works because it continuously takes a little bit of traffic as well. Maybe it's a 90-10% weighted routing on Route 53. And lastly, everyone, you have a multi-site active-active, where we don't even have a recovery environment. They're both the same size. So it doesn't matter which one fails, really, because the other one will be there to take the load. So that is the idea, everyone, of RPO and RTO. Like I said, if one of them fails, the other one takes almost instantly everything, so you shouldn't even feel it if it's done correctly. But of course, this will be the most expensive. Ultimately, everyone, it's a balance between cost and speed. Speed defined by RPO and RTO as well. And those are results based on the configurations of your solutions. Thank you very much for your attention on this one, everyone. Do we have any questions?
I've one question. When we take a AMI backup, that is AZ dependent, isn't it? You can't. You've got to explicitly export it to a different AZ.
So it is region specific, actually. So it's because an AMI is technically an EBS volume, snapshot of the volume on your EC2 from where you're taking the software. So let's have a look here on EC2s. But it is region specific, so it will have a regional ID. If you want to move it to a different region, it will have a different ID. That tends to be an issue in CloudFormation templates. Reason why we have mappings and parameters as an example, which is something I can show you in more detail if you want there as well. But in the meantime, hopefully this is going to load quicker here. There we are. So, AMIs, we can see it's region specific and not AZ because I can launch, let's go with mine. I can take an AMI and I can say, launch an instance. Any second now. Launch an instance in any subnet. Once this loads here, there we are. No preference, but I can choose if I want to different availability zones.
Okay.
It's behind the scenes, it's stored in an S3 bucket that we don't see and we don't manage, but deep in documentation that is mentioned as well.
Okay.
That is perfect. Let's get rid of some of these. There we are. All right, everyone. In that case, let's have ourselves a knowledge check to sediment what we've done. So this will act as our coffee break, if you will. Like we said, it's a slightly longer stretch here, but we don't need to basically go through more elements. And if we took a coffee break, that would take a little bit longer. So you know what? Let's do it the following way. I'll put a 10-minute or let's say a 7-minute timer here for you to grab some water, stretch your legs, grab a coffee. And whilst you do that, please also join the quiz so we can have a final review here of what we've learned. How does that sound, everyone? Let's see. Oh, let me copy the quiz ID here so it's easier as well. There we are. Okay. Ooh, let's see. Copy event link. There we are. There is the link as well. All right, everyone. Join in. I will stay on camera as well. Actually, I will go grab some water quickly and I'll be back in 1 second. But take advantage of this time to join in and to grab some coffee as well. I'll see you in a few minutes. All right, everyone. We are back. Well, I am back, but I'll wait until the timer is up to start the quiz. So please take your time. No need to rush back. All right, everyone, welcome back. Hopefully, you've had a chance to get a quick coffee break there as well. Might as well as we were joining in the quiz. Let's get started with question number 1 in just a few seconds here in 3, 2, 1 to review what we've learned. What is a feature of SNS? Ten more seconds left there. I can see the answers coming in. And the correct answer is, with an 100% achievement rate over there, indeed, it can publish to multiple subscribers. So as part of this course, we've learned about serverless tools such as SNS, which is a one-to-many messaging system, SQS as a one-to-one solution that can wait in that respect, an API gateway as an API management tool, serverless compute with Lambda, and more, such as the Kinesis suite as well. All at high level, of course, because we don't really dive that deep in this course, but still understanding of where we can go from here. So well done, everyone. Let's go to the next question. What is an AWS CloudFormation stack? A few more seconds here. So we have an most majority here with the first answer, and that is indeed the correct one. It is the resources defined in the template. So everything that we talked about here and here, whether it's a network aspect, even IAM, users, groups, or roles, elements that we've learned about on day 1, whether it's any of these elements, everything can be defined in a CloudFormation template. So infrastructure as code, everyone, written in JSON or YAML to define one or more of these elements. Absolutely. And stack are the provision resources. Well done. Let's look at the next question here. What is a connection to a transit gateway called? So we have mentioned this, but because we don't go into a lot of depth, maybe we might need a refresher. Quite a few options here, but the correct one is indeed attachment. It's just what we call the connection between the way transit gateway connects into a subnet. So as part of this course, from a networking perspective, we learned about the virtual private cloud as a collection of private IPv4 addresses in the cloud. that can have subnets which can be exposed through route tables in an internet gateway to the internet. We learned about NAT gateways as well in that respect, and the ability to connect to multiple other VPCs through either VPC peering or even transit gateway as a hub in between multiple VPCs. And also, of course, to a on-premise solution via Direct Connect or VPN. Well done on this one, everyone. Let's have a look at the next question here. What are two potential benefits of implementing a CloudFront distribution? Something we've learned just recently, but we have talked about a few times here. We are getting responses, and 10 more seconds left. So we have responses all across the board, but the overwhelming ones are the correct answers. It is for increasing security and reducing latency. CloudFront, remember, takes advantage of those edge locations as a network solution, and it is for distributing content around the globe, but it doesn't cache on-premise as the last option there mentions. So it doesn't do on-premise caching, and it doesn't increase redundancy of the application content itself. Imagine you lost the origin, but not the CloudFront distribution. That means ultimately your data in CloudFront will expire as well. And this option here refers to Global Accelerator. So well done, everyone. Next question. A network engineer wants to route 80% of web traffic to AP Southeast 2. The remaining 20% will be directed to EU West 1. What Route 53 policy is best here? There is just one choice. Ten more seconds. So quite simply, everyone, if we want to control percentages in Route 53, we use weighted routing for that, absolutely. Geoproximity is for location, geolocation is for location geographically, and geoproximity is us redrawing the map. Simple routing, no logic, no particular logic there as well. And Route 53 is our DNS-based solution that also lives in the edge locations. Basically, that's where we resolve our DNS over our name servers. Remember, you can have private and public hosted zones as well. Well done, everyone. Let's go to the next question. Which of the following offers DDoS protection? Two options here, two services working together. You can even find them together in the console. Ten more seconds. So absolutely, it is Web Application Firewall and Shield. Shield is the designated DDoS protection solution, but together with WAF, it can filter based on clever rules as well, part of web access control list. And with Shield Advanced, remember, you also get cost protection and a dedicated SRT. Next question here, everyone. Which descriptions are characteristics of microservices? Just a few more seconds. There we are. We have all the answers in, and it's about being decoupled or loosely coupled and about being autonomous. Think about it this way. In some of our examples here, let's see. We don't have any on the board, but let's see if I open one. Actually, I know where I'll show you this. There we are. In lab number 6, we have an architecture here where we could ask, sorry, not lab number 6, lab number 5, my apologies, in the serverless one. There we are, any second now. So we have an architecture here where we have multiple decoupled elements. If this lambda function 1 fails, will everything else still work? Absolutely. This flow will not work, of course, as the logic, but it doesn't take down everything with it. It's more independent. Now, of course, the SNS topic is a single point of failure in case this goes, if this has any issue, then nothing gets generated. But that's about architecting it more highly available as well. And it is unlikely for serverless solutions to fail. They are more highly available. But the idea is, in terms of microservices, we are decoupling our functionality in that respect. So they are the opposite of tightly coupled, essentially. Well done, everyone. Next question. What are the components of site-to-site VPN connection? Five more seconds. I can see the answers coming in. That is perfect. So it is the customer gateway and the virtual private gateway in that respect. The others refer to different types of private connectivity here, but not, of course, not VPN related in that respect. Let's go on to the next question here, everyone. Which statements are benefits of using CDKs with CloudFormation? A bit of a longer question here in terms of reading, but the exam does feature some of these as well. So I can see answers coming in. A few more seconds. Let's see what the right answers will be. So the correct answers are the overwhelmingly ones, and that is absolutely right. You can use common programming languages and pre-configured resources like through classes, methods, and the like. And you do need an account and credentials to work with CDKs, and you're not limited to just one user as well. And unfortunately, there aren't any bulk discounts. So CDKs are infrastructure as code through a common programming language. Next question, everyone. Why would you choose Fargate over EC2s? A few more seconds here. And indeed, right, it's about avoiding that physical infrastructure as much as possible in that respect. It's not to take control of it. Imagine with the EC2s, you have more work. With Fargate being serverless, you have less work over that infrastructure. Next, and the last question here, everyone. What is the benefit of choosing Outpost servers when compared to an Outpost rack? So basically, the small one versus the big one. The Outpost rack being the cabinet, the big one. So it is basically good for location constrained locations. So if you have a small room, maybe you don't have a space for a big cabinet of servers, so you would just get one server. Well done, everyone. Hope you've enjoyed this last quiz as well. Let's see who's taken the lead here. Pravin, fantastic work. Great job with all correct answers here. And Amin next and more as well. So fantastic work, Pravin. Very, very well done. And it's not just about the small friendly competition here, everyone. It's about the knowledge as well. So hope you've enjoyed going through some of these questions to reinforce your knowledge and to review the content that we've gone through. Right, this takes us here to the end of our course in terms of teaching. So let me take you through the course summary before you are able to complete lab number 7. If you want to complete it now or later as well, that's perfectly fine. I will be here until everybody finishes as well, or at least for another hour, I would say, until 6 o'clock British Standard Time. But in the meantime, just to give everyone a chance to also adjourn and enjoy your weekend, let's go through the course summary first as well. So everyone, we've learned in this course about how to architect on AWS. We've learned about identifying AWS services. We've learned about networking and how to build architecture resilient and secure solutions on AWS. We looked at compute, networking, and IAM, or across multiple accounts as well with organizations. Then we started exploring storage in multiple facets with S3, EBS, EFS, and more. And then, more specifically, database solutions there, relational and non-relational also. We then looked at high availability with auto-scaling CloudWatch and Elastic Load Balancers, which are also of multiple types. And then automation with infrastructure as code mainly, but other options also. And containers with Docker-based ones and Kubernetes-based ones as well. We topped it off with advanced networking as well, going beyond single VPCs, looking into serverless with API gateway and messaging services, moving to the edge with Outpost, CloudFront, and RAW 53 and protections with WAF and Shield. And lastly, we looked at different ways to ensure, even if something fails, how do we recover from it in a cost-effective manner. We recommend you continue your learning to study for these certifications, with Solutions Architect Associate being the closest to this particular course. We recommend you have a look at Skill Builder. So do save this QR code or scan it now and bookmark the webpage and explore Skill Builder for a lot more content, both video, game-based, and self-paced lab environments as well. Basically, on Skill Builder, you can get, I think it's about 150 plus labs at this moment in time. The number keeps changing, so I do recommend you explore this in a lot more depth as well. I will talk more about certifications to the people that are in interested as well. So I will do that as a separate discussion if you want. Yes, the previous slide, absolutely. Is it this one here, Jacek? Yes, there we are. So no problem at all. Let me know when you're okay for me to change this. Ultimately, everyone who wants to take the exam, do let me know and I will give you some more details on that. But you will also find them through these guides that are in the slides here. So I don't want to spend all too much time on it if it's not of overall interest, so to say, but we will go into a separate detail as well. Now, everyone, I will kindly ask for a favor as well, if you don't mind, and that is for some course feedback here. We, of course, try to make this experience better and as best as possible every time we deliver it. So there will be questions in the feedback form about the labs, about the environment, about the course content as well, and more importantly to me personally, 3 questions on the instructor. Now, to give you a bit of context here, these questions relate directly to my performance, and they are essentially translated behind the scenes in a 5-star rating system. So, of course, please be honest in your feedback, but if you've enjoyed the course, if you've learned something new, and hopefully had fun doing so as well, please give it a 5-star rating as well. I always enjoy looking at the comments too. Even if it was a fantastic delivery, I always like to see if maybe there was something that was particularly enjoyable, as well as, of course, what people's thoughts were. So you should all receive any second now confirmation of attendance and the ability to leave feedback here. So let's see as well, just to make sure. There we are. So you should receive confirmation of this shortly. Let me say thank you very much once again, everyone. Please take the following 10 minutes to leave feedback and then carry on with the lab as well. So let's put this on the screen. Oh, this doesn't work. Oh, there we go. There we go. Let's call it like this. Let me just say thank you very much once again, everyone, for joining me on Architecting on AWS this week. It's been an absolute pleasure on my side. Hope you've enjoyed as well. Hope you've learned something new and hope you had fun these 3 days learning more AWS and that it's been useful. Thank you very much, everyone. I will leave you in peace to leave feedback and carry on with lab number 7, for which I'll be here to give you a hand if you need to. Thank you, everyone.
Thank you, Stefan. Very good.
Thank you so much.
Thank you.
Thank you as well.
Really great. Thanks.
Thank you.